Is that
Yeah.
on the first slide there? Okay. So my details will pop up again at the end. I was just talking about the Biochar Industry Group logo there as well, which you can also Google, because there's a number of projects that I support at the board level, and I also help develop business cases for biochar projects. The circular economic opportunities for biochar and agriculture is similar elsewhere. The main thing when biochar is used, produced and used on a farm, there's obviously the opportunity for increased agricultural production, and that's some of the work that I'm doing now, is aiming to get various kilns, or depending on the size of the biomass, out onto properties where biomass is made on properties, and those units can be, if you like, mobile and moved to other properties, and biochar can be processed that way. I think the important thing is about the cyclic carbon, which I'll come to, the recycling of carbon and how important that is, but also the mitigation and adaptation, as we know, to climate change. But in South Australia, we are the driest state in the driest continent, so the improved water savings and improved water quality is extraordinarily important. I sit on a board which is about the Murray-Darling, and this is our only river system through much of eastern and southern Australia, and it's declining in its. We manage it within a millimetre of its life, and so biochar is very important in the use of water savings as well. I think you probably covered off on the value proposition of biochar. I have missed some of the other presentations, but for those that aren't here, obviously in agriculture you can take any waste, depending on the technology, and then turn it into biochar, which can be up to 90% carbon. But then depending on the technology, you have these other byproducts being energy, biodiesel, bio-oil, biogas. And one of the main things that are a useful byproduct for agriculture is the wood vinegar as well, because it is a biostimulant. When biochar is made, it's the special properties that are important to agriculture. So one of the main things I talk about is that cation and anion exchange capacity. So when biochar, because it's highly porous and has high surface area, 1 gram of biochar has the same surface area as a house. And each of these surface areas can exchange cations with minerals that are available in the soil, but also available in an animal or animal feed. So when it's put into the soil, it stimulates these cations and anions to be more available to the plant, and then the minerals are taken up and absorbed by the plant. It's like putting a battery into the soil. But the same effect happens when you feed biochar through an animal. It makes the minerals in the animal feed more available to the plant. But going another step further, if you feed biochar through an animal, we've actually tested many manures and have found that the minerals are also retained in the manure. So in the dung, and the biochar with the manure that still contains that biochar because it's not absorbed. And we found that there's higher nitrates in the manure and higher minerals, and essentially makes a really good fertiliser as well. When you're making biochar in agriculture, of course, there's many, many uses, and I think that's confusing for many that are using biochar in agriculture, because 1, you have a range of feedstock. 2, you have a range of temperatures in which you can produce that biochar. And 3, there's a range of technologies that can be utilised. And so there's confusion in terms of how that biochar can be used in agriculture. The way around it, I believe, is certification, which the Australian New Zealand Biochar Industry Group are doing, as well as the International Biochar Industry Group. And but there's also companies now in Australia that are wanting to combine, as Osman talked about, those biochars with synthetic fertilisers as well as organic fertilisers. And those companies, if they certify their product themselves, then that gets away from all these variabilities in feedstock. Currently, there's only about 20,000 tonnes of biochar annually produced in Australia, but the Australia-New Zealand Biochar Industry Group are producing a roadmap and want to increase that to up to 250,000 tonnes. And there's some case studies I'm going to show you shortly that are really well on their way to doing that. Here's a range of technologies. Obviously, we know we have stoves, and these are the type of technologies that are being used in agriculture, stoves and batch kilns and portable kilns. But then the continuous kilns are those that are used for higher numbers of biomass to process much larger tonnages. At the moment in Australia, we have prototypes that can produce 5 tonnes per hour of feedstock, but at the moment they're not commercially available. So our best option at the moment for these continuous kilns are 1 tonne per hour units. Okay, so some case studies, just going to some case studies. This is a case study not for agriculture. This is a biosolids to bioenergy gasification facility used by a municipal council. They're converting biosolids into biochar, gas and heat energy. Here's another example. It's called the Echo 2 prototype. They're using multiple feedstocks. And they are using the energy to replace LPG. They sell the biochar and gain carbon credits, and they produce hot water that heats a glass house, and so they're able to obtain reasonable carbon credits. This project here is, I can't change slides for some reason. Here we go. This project here is on an island off of the coast. There's 6 million tonnes of timber, and that can produce 1.5 million tonnes of biochar. It is burnt timber from bushfires on farms. So this is one of the big agricultural projects. That biochar is going to be used to remediate the farms who have acidity problems and phosphorus issues. And we know that biochar in most cases always improves phosphorus availability in soil, but also pH. This is a big project. It will be one of the largest in the world globally if it goes ahead, and there's a number of business cases and revenue raisings going on to make that project real. So I guess to recap, the value proposition for biochar and agriculture, or the revenue opportunities, the sale of carbon credits, sale of the biochar, sale of syngas, biodiesel and wood vinegar, heat energy for renewable energy, job creation, your waste is utilised, but more importantly, your production and profitability is increased. I'm talking about the cyclic carbon now. The important part about using biochar in agriculture and back in the soil is it replaces the soil carbon. Globally, we've released 50% of the soil carbon to the atmosphere. So biochar captures and stores that carbon, and it's a way to replace that organic carbon back into the soil. Why do we want to do it? Because every 1% increase in soil carbon you will get 10 to 30% increase in production, and you will also get 10 to 30% increase in water storage. And in a dry state, in a dry continent, it is extraordinarily important. The other value proposition for this is that globally we need to remove 8 billion tonnes of carbon dioxide from the atmosphere every year by 2050. By using biochar in the soil, you gain this cascading carbon benefit in the presence of plants, where we find soil carbon will increase 20-fold in the presence of plants when you add biochar, because there's a combined effect of the various types of carbon in the soil that has this cascading growing benefit of soil organic carbon. So there's a book called The Biochar Solution, Carbon Farming and Climate Change. It touches on a whole range of benefits, including how it increases crop yields, improves animal production, feed conversion, milk yield, soil carbon, greenhouse gases, improves soil health, mineral availability. But just to talk about some of the projects that I've done, I've fed biochar through animals and conducted many trials. They're available on my website, and we've published papers as well. And when you feed biochar through an animal, you get a range of benefits that I've touched on, like improving milk yield, increased animal weight gain, improved conception rates, but also we find that we need to feed less feed, but we gain more production. The benefit feeding it through an animal is the biochar is not digested and ends up in the dung. And we have dung beetles that we've released prolifically around Australia because the dung beetles can then bury that carbon-laden dung and get it into the soil. So it's a really easy way of improving your soil carbon, but it's a higher order use, if you like, because you're getting the benefit through the animal into the manure as a fertilizer, if you like, and then into the soil to benefit the soil. It then has ongoing benefits to the plants and the soil health. So it's a really popular way in Australia of spreading biochar, especially when you have existing established pastures. If you want to use biochar in cropping, obviously they're annual, and it's there's a bare surface of soil, but in pasture situations, it's difficult to get biochar back into the soil. So this is a really great way, because obviously pastures are grazed by animals, and so it's a great way of getting that back into the soil, increasing the soil health, soil carbon, productivity, and so on. Like there's a range of benefits and I'm not, because I know I'm running out of time, of what happens when you feed through an animal, which I've touched on. But I just want to talk about the biochar dung and soil again, because as an analogy, in Australia, in our dairies, we might have around about 250 cows. They'll do 5 tonnes of dung in a day. That's 1,825,000 tonnes in 1 year. So over 200 hectares, that's a spread rate of 9.1 tonnes per hectare of activated manure. In Australia, we generally spread synthetic fertilisers at around about 200 kilos per hectare. And organic fertilisers are more expensive, so you might spread them every second year at something like 500 kilos per hectare. Who spreads fertiliser at 9.1 tonnes per hectare? But this is what happens when you feed biochar through an animal. It really basically turns that manure into a really a great biofertilizer, high in nitrates, high in phosphorus, high in minerals, and that can be spread across the property. In the presence of dung beetles, it can be incorporated, but also earthworms and the like. There's 14,000 published papers on the benefits of biochar in soil. You might like to look at this paper, Joseph et al. There is another range of meta-analysis that have been done. Consistently, they find increase in phosphorus in the soil. Consistently, they find decrease in heavy metals in the soil. Consistently found building soil organic carbon. And I mentioned how when you build your soil organic carbon, you increase your production by 10 to 30% and your water holding capacity by 10 to 30%. Biochar could be used to save water. In Australia, with our river system, we have a very regulated system, and the policy at the moment talks about improving irrigation efficiencies. And my advocacy that I've done is talking about the benefit of biochar because of its water saving capacity, and that we should not look past it, because it can hold the water in the soil because of its porosity and its surface area. The other thing is that the average benefit that we're finding in Australia for biochar changes depending on where it's being used. In those horticultural situations, we're getting about $20,000 benefit from 1 tonne of biochar. So if you average the benefit to agriculture of just $2,000 per tonne of biochar, and 5 million tonnes of biochar is used in agriculture per year, the net benefit to agriculture would be $10 billion. And we need to improve our food security. This is a way of improving that food security. This is a paper that's been also on the Australia-New Zealand Biochar Industry Group website, talking about the net benefit per tonne of biochar used. Obviously, there's other emerging uses of biochar in Australia. So there's emerging uses for biochar in roads, biochar steel as a replacement for coking coal. Both steel and roads are huge emitters of carbon. So there's other uses, but the best, most high order use of clean biochar is in agriculture, because it can build that soil carbon. And I think that's why it's recognised through the International Panel on Climate Change as being able to reduce emissions globally by up to 2/3 because of its cascading benefit and potential in agriculture. But again, also when you feed biochar through an animal, you're also reducing methane, and that's as a potent carbon dioxide gas. And there's recent papers out as well that show if you add biochar to the effluents of dairies, and also when it's added or in the manure, it actually reduces the methane from that manure or from the dairy effluents or piggery effluents and the like. I think that I'm pretty much out of time, so thank you for having me. And I just finished off with those value propositions of use of biochar in agriculture, thinking about that circularity in agriculture and how biochar can benefit a farm or a region. You can find more details on my papers and work on my website. Thank you. I'm happy to take questions if there's time.
Yeah, thank you, Melissa. So, is there any questions about Melissa Rebbeck's presentation?
Hello, Melissa. Thank you for the great presentation, but my interest is at the level of the cow manure used for biochar. My point of interest is this. I wanted to know from you, because considering the energy that will be used for pre-treatment and treatment of cow manure before paralysis, what do you see as benefit compared to production and commercialization?
I'm not sure I understand the question. Sorry. I'm just sort of thinking about Osman's presentation before. Is it about should you paralyze manures? To me, if you can, I'm not sure if that's the question, but to me is if you feed biochar to an animal, it no longer releases as much methane and it's turned into a bioactive biostimulant fertilizer. Then getting that back into the soil would be important with dung beetles. But also you can add biochar to manures, and then that does reduce. So there's papers out now to show that significantly by 60%, 70% reduces the methane from manures as well. I'm not sure if I've answered that question. If you want to clarify it with a follow-up, I'm more than happy to answer.
Hello, I am Andres. Melissa, really, I like it very much. Your talk really was a pleasure. I think I need to contact you by one thing that I have in my head, just to idea. Okay, just only that. Thank you very much.
Please do. Anyone that has any questions, please send me an email and I'm more than happy to answer those questions.
Just a quick question, Melisha. This is Sumit Sharma from India, and I would like to know what percentage of biochar you give in the feed to the animal.
Less than 0.05% of their intake. And in fact, some of the trials that I've done, I've asked the farmers to feed less 0.05% of their intake, and which works out to about 500 grams per head per day. And one of the farmers, I ended up putting in 150 grams in a dairy and still had fantastic benefits.
Okay, thank you. Thank you very much.
Hello, Melissa, Yaspal here. So after addition of biochar in cattle feed, will it be digested or it will come as it is in a cow dung?
It's not fully digested. It's partially digested, and we have tested manures to find out how much residual biochar is there. So, you know, we're finding at least 70% of the biochar remains in the manure. So it's not fully digested. And on the way through the rumen of the animal, something amazing happens. I mean, it still benefits the rumen, the animal, but yet there is still higher nitrates remaining in that manure and minerals.
In some of the papers I have read, adding a biochar, it inhibits the methane production as methane production. And other way, if we add biochar in a digester, it enhances the methane production. Can you please clarify?
So I understand the process of how biochar can inhibit the methane production through rumen, but I'm not sure through an anaerobic digester. Is that what the question was? So and it depends on the biochar. So my colleague, Professor Joseph, has done some research where you feed biochar in it to an animal, and the animal's in a chamber, and he's found it depends on the biochar type, but it combines with the methanogens in the rumen and inhibits the production of methanogens, which is the gas that produces the methane, and that is how I understand it works. There's also this rumen active process, which I understand impacts the cation and anion exchange capacity, as I spoke about, and makes the feed more convert to energy and weight gain. Convert to weight gain. If you are having better feed conversion, you'll also produce less methane because the animal is growing faster on less feed, and so there's then less methane production. I'm not sure if that explains it. I don't understand the process in the anaerobic digesters, if that was the question. I'm not an engineer.
Yeah, correct. No, I got up to some extent. It's okay. Thank you.
That's okay.
Hi, Melissa. Am I audible?
Hello, how are you?
Yeah, I'm good. Great presentation by you. Thank you so much. And actually, I'm curious to know, are you doing any methane avoidance for project for carbon credit generation from your project?
Some of my colleagues are doing some work in that space, but it needs to improve, and there needs to be more work, because we have a thing in Australia where if we can prove that the biochar through science can reduce methane, then our farmers can get a rebate back for reducing the methane. They can at the moment get a rebate back for using biochar in the soil and from the Australian government. but we need to do more work. So there's a number of projects at the moment underway that are going to be published soon, and we are lobbying the Australian government so that we can recognised. But at the moment, it's not recognised because the work needs improvement and needs to be published.
Okay, thank you so much.
I have a question, Melissa. Thank you so much for your presentation, very insightful. So my question is, very earlier you were saying you use digester to produce the biochar. So there, I'm very have a concern about the cold manners. So, is there any pens or the animals are put in enclosure somewhere that you were able to gathering the manure and put it in the biodigesters, or are there the shepherds who go around the way with them, or how do you manage it? Because I'm asking because there are some places here in Benin, because I'm from Benin in Africa, West Africa, and the shepherds, some shepherds go around with the animals they cause to along them to find feeds to eat in farms. Sorry. So is there any enclosures or pens where the cows are bucket and it allows you to collect the manures easily? And how many tons are you able to find the sufficient amount of the manure per day that you put in the digesters?
I'm not sure if I understand that question, but I'll just say a couple of things. In terms of feeding the biochar to animals, there's two. You can easily get biochar into animals in feedlots, big feedlots, and quite easily in dairies because there is rations that are fed at dairies. It is much harder when you have grazing animals across broadacre situations. But I have animals that are broadacre, not as widespread as Africa, but what you need to do is basically where in each paddock where the animals are, you can just put the biochar out. And we have initially mixed it with molasses, but over time they will eat it just plain because it's like a lick, becomes like a lick, and they will eat it and they will ad lib because they're lacking something. If they're lacking something in their diet, they'll eat it. I'm not sure if that's the answering your question though. So you might